Hi, everybody. Welcome back. So I want to take a minute and talk to you about chaining operations together. We've throughout these videos, we've talked about filtering and getting down to certain rows that you care about. We've talked about arranging, and that's reordering rows based on some criteria. We've talked about selecting, which is looking at columns and either pulling out columns that we're interested in or discarding columns we no longer want, or rearranging columns, renaming columns. And then kind of drilling down to sub cell and out like getting into the subgroups of the data set with group by and summarize and say, okay, well, I want to look at these columns, but I only want to look at them within this set of rows. So kind of like zooming in on the data and summarizing what's going on in a smaller group of the data. Now we want to put all of this together and see if we can actually think through a process. Okay. So let's say that someone asked you, is there a relationship between the flight distance and the arrival delay? Well, this is something that we can do with a combination of both the verbs that we've used in dplyr, but also some of the ggplot figures that we learned a few lessons ago. So the first thing we're going to do, we're going to take the delay, we're going to create a delays tibble. And so we take the flights data, we group by the destination, and then we're going to summarize a couple of different columns. So we're going to say, okay, well, how many flights actually was in this group? How far did each of the flights go and remove missings? How long was the flight delayed and remove airports, remove missings? Sorry, I got ahead of myself. And we said, okay, well, Honolulu is just kind of off on its own. It's literally on an island, just far away from the continental United States. So we don't want this to be in our analyses because the distance is going to be way farther than everything else. Also, we don't want really, really tiny airports. Like if you had a small private plane that flew from New York to some little tiny airfield in the middle of Rhode Island or something, that's probably a charter flight, some rich person's private jet, and they can have whatever delay that they want because they own the plane. So that really shouldn't factor into our analysis. We want to look at the standard flights that are going from New York to just airports that are just under a lot of use. So that's why we're saying, okay, get rid of the small counts. We've got 337,000 to work with. Let's get rid of the airports that we don't have a lot. And that's one of the other reasons why we needed to create this count variable. So now that we have this delays data set, and the delays data set has the count, so the number of flights that went into that destination, it has the distance that the flight traveled, and it has the delay, how long the arrival delay was. Now we can plot it. So notice what we're doing here. On the x-axis, we're putting the distance. On the y-axis, we're putting the delay. And then the scale axis, the size of the dot, is how many flights. So that means that really, really tiny dots are things that we don't have to spend a whole lot of time working on. We want to drill in and focus more on the larger circles, because that's telling us like, okay, well, these are representative of tens of thousands to tens of thousands of flights. And you can see here there's this almost like a little hump shape that shorter planes, maybe they don't have you. If you've been on a plane, maybe you've heard the pilot come over on the intercom and be like, hey, we were a little delayed getting out of the airport, but we're going to try to make up the difference in the air or something like that. So maybe the longer flights, like if they're longer distance flights, there's a chance that they can go a little bit faster and make up the difference in the air, or they take a more aggressive route or something. I'm not a pilot. I don't really know how it works. But perhaps if they're shorter distances, there's not as much flexibility for them to make up time in the air. And so you sort of see this hump here that if there was in shorter distances, the delay is a little bit higher, but in longer distances, maybe they're able to get into a nice air current and just glide. So we could think through like having a hypothesis related to this based on this figure. So if we wanted to, another example, it would be adding and visualizing counts. So let's look at the average delay by plane. And so this would be like a histogram, if you will. Notice there is a way for us to have negative arrival delay. That's if the flight showed up early. So this isn't just fake data. That there are flights that we had negative arrival delay for, and we actually saw that above. That for instance, getting into Honolulu, on average, you showed up a minute and a half early. So that would be some flights over here that are really close to zero arrival delay, but technically negative arrival delay because they show up a minute or two before they were supposed to. So we go back to the not canceled data set, and then we group by tail number. So this is the plane itself, because a lot of times maybe it's the same flight crew is using the same plane. So let's look at like, okay, well, we don't have data on the flight crew itself, but perhaps we can think about the plane itself, and maybe there's maintenance issues with this plane, or maybe there's something about this plane that is for whatever reason it's causing some wind drag. Are there planes that are on average, they just have longer flight delay or something? And then we can summarize across the different planes, what was the average delay? Okay. Now, if you look at this, we're plotting this, and there are certain planes, these are individual planes, that on average are delayed multiple hours. Well, I mean, really? An entire plane on average delay of over 5 hours? Hold on, that doesn't make a whole lot of sense. So we would actually want to add on a counter that says, well, how many flights did that plane make? If that plane only made one flight and the flight was delayed 5 hours, well, that kind of makes sense. I mean, yeah, there's something weird happened, but it only made one flight. So so the average is being pulled by the fact that there was literally only one flight and it had a long delay. So what we can do then is we can go back into the summarize and say, okay, well, here's the delay, but also give me a count of how many flights that happened there. And so you can see here, and we're going to put it ggplot, we're going to plot this, and we're going to put the number of flights on the x-axis and the delay on the y-axis. And you can see here that the flights with the average delay through the roof, these are all planes that had one flight, two flights, maybe. And so the average is very, very, very high. We see right here, this plane that had an average flight delay of upwards of 300 minutes, it had one, maybe two flights. But the planes that have lots and lots and lots of flights, this is happening regularly. You can see here, on average, their delay is, I don't know, maybe 20, 30 minutes. Not that bad for an average delay. Some of them, you see they're even below zero, that on average, these planes they're leaving early or they're arriving early. They're able to make up great time in the air or something like that. But the other side of this is, if you look at this, we're not really able to see what's going on, because there's a whole cloud of points here closer to with let's say fewer than 30 flights or fewer than 20 flights. So what we can do then is we can say, okay, well, let's just get rid of all of the planes that didn't fly at least 30 flights. Because if we want to take averages, we want to have at least 30 flights to work with. So let's cut out those. So we're going to start with the delays data set, and then remove any flights that had fewer than 29, or remove any planes that had fewer than 29 flights, i.e. keep all of the planes that have more than or equal to 30 flights. And then we're going to plot this. And we're going to look at, with the horizontal axis being the number of flights taken, the y-axis being the delay, and then we're setting our alpha here to make sure that the points don't crowd each other out. And you can see that there's not much of a relationship here, if there is a relationship at all. But you can sort of see what's happening with the data. And you can say, okay, well, still there's the flights that had very, very few flights, even cutting it off at 30. There were still some planes over here that like this plane up here probably had like 30 or 40 flights throughout the year. So that's less than one flight a week, and an average of an hour delay. This is still probably a private jet. But you see here where once you get into saying, okay, well, there's at least one flight a week, that would be 52. So 52 weeks in a year. So past this point to 50, you start to kind of stabilize and get to this more reasonable area where even the crazy delayed flights are only delayed on average by like half an hour, which you still kind of, or the arrival delay is only about half an hour, which you still kind of worry about that. Like, why is it that on average you're showing up 30 minutes late to your destination every single time? But nothing crazy like up here where you've got literal 5-hour delay times. And then we can make so if you see here, there's sort of like a histogram, but looking at it this way, so you kind of tilt your head and you see a bit of a histogram. Well, we can actually make that histogram, and here it is. So here's our average delay for all of the planes that had at least, or had 30 or more flights. And so you can see that there's a decent number of planes that they didn't have an arrival delay at all. They actually got in early. A good chunk of planes that on average they were only about 5-10 minutes late. And then you've got this tail over here where there's a couple of planes where they're just showing up whenever they want, you know. So anyway, that's where we've got our histogram. So there's a couple of other use, like some other things that we want to do. So passengers are usually not going to complain that their flights are early, but they may complain about the departure delay or something. So the true delay would be the difference. And so we can say that there's the average delay here, but then the delay that people would complain about would be the non-negative average delay. Because these arrival, I'm sorry, the non-negative arrival delays. So arrival delays can be negative, but that's actually probably a good thing, you would imagine. And so we can use summarize here. Again, notice the logical subsetting that I'm doing. I'm saying I want to take the average of all of the arrival days, but only the arrival days that are greater than 0. Only the ones that that customers would complain about. Again, here's another example. We've got proportion of flights that by day. So we're grouping by the day and finding out the proportion of flights where the arrival delay is greater than 60 minutes. And we could look at this over time and see, are there points in the year where you just have a lot higher delays? And we could look at this by region, say, okay, well, we know in the summer in the Midwest, there's a lot of huge thunderstorms. Maybe that's causing arrival delays and so forth. And so we can just go through a whole bunch of this stuff. So here's we're summarizing by standard deviation and then decrease. So these are the most variable destinations. So these are the destinations that have the highest variability, the highest spread in the delay. And maybe notice a lot of West Coast things over here, because perhaps there's more chance for them to run into weather over the Midwest, run into weather over the Rockies, things like that. Let's see. So this is a quantile. So this is the 25th percentile of departure time. And then right here, another thing that we can think about is a lot of times we could instead of just typing n equals n, summarize n equals n, because we've done that quite a few times. There's actually a shorthand for it. It's just count. So count is a group by and summarize all together, but it just counts. So say, okay, give me the total number of flights into each destination. There's going to be 104 destinations. And this tells me everything. A ton of flights into Atlanta. So Delta probably is flying from New York to Atlanta. So, and then we can weight by distance, a lot of things that we can do here. And this is where I'm going to pause. I'll pick this back up in the next video. We'll talk about grouping multiple variables and then talk about joins as well. So I'll see you next time.